Let's take a look at trigonometry word problems. I've listed some steps here that I'll go through, and then we'll be following these steps as we go through different types of word problems. So step one is to draw a well-labeled diagram. Sometimes you're given a diagram that goes with the word problem and you may need to add to it, but many times there's no diagram and you need to do your own from scratch. Step two, decide which strategies to use: primary trig ratios, sine law, and or cosine law. You may need to use a combination of the different strategies that we've learned so far. Step three, solve for the missing values. Round all lengths to one decimal place, all angles to a whole number, and include proper units. So the question may say to round to something different, and that's okay, just follow the question, but as a default, lengths to one decimal place and angles to a whole number. And lastly, we want to write a summary sentence or to paraphrase to just sum up our findings. So first off, we're going to take a look at some different descriptive words we might come across in word problems. So the first one is angle of elevation. So let's take a look at what that looks like. So angle of elevation is if you imagine looking out and then looking upwards. Okay, so these angle of elevation, and next we're going to go to angle of depression, they're all from the perspective of the observer. So I just like to think about a floating eyeball. Okay, so looking out and then up. And then we're talking about the angle right inside there. So this here that I'm highlighting in yellow, this is called the horizon. So you're looking out at the horizon and then up, and you might be looking at like a bird flying in the sky or something like that. So this is the angle of elevation. So looking up from the horizon. This one is usually fairly easy for students to comprehend. It's the next one, which is the angle of depression, that people sometimes have difficulty with in the context of word problems. So with angle of depression, you're looking out at the horizon again, but then you are looking down. So let's draw in our eyeball. So there's our eyeball looking out and then looking down. And maybe you're looking at like a bug or something that is on the ground. Okay, here's my little ant. And you're looking across at the horizon and then down. So this is really important because a lot of students confuse this one and think that you're looking straight down and then up. But no, you're looking out and then down. So angle of depression. Looking down from the horizon. So in both the angle of elevation and the angle of depression, here we can show both at the same time, you are looking out first. And it's looking out parallel to the ground. And that's what's really important to remember. That we're talking about the horizon and then up or down. Okay, so with that in mind, let's get to our first example. So in our first example, we have Kim, and she's looking up at Ted's window from her apartment. The angle of elevation to the window is 20 degrees, and the angle of depression to the ground at the base of Ted's building is 40 degrees. If the buildings are 30 meters apart, how high up is Ted's window? So this is a lot of information. We want to break it down. So Kim is looking up at Ted's window from her apartment. So I'm going to draw Kim's building. There it is, mostly straight. And she's looking up at Ted's window. So I'm going to draw Kim. Here's Kim right here. Label it with a K. And she's looking up at Ted's window from her apartment. So that means that Ted is higher up than her. And we're later told that there's another building. Ted's not floating in the air there, but Ted's in another building and he is higher up than Kim. So Kim is looking up at Ted. Now the angle of elevation to Ted's window is 20 degrees. So that means Kim's looking straight out and then up. Okay, so there is 20 degrees. I'm going to zoom in while we do the diagram here. And then the angle of depression to the ground at the base of Ted's building is 40 degrees. So that means she's looking straight out again, and then she's looking down to the ground at the base of Ted's building. So this right in here is 40 degrees. Okay, so notice for both, we are looking out at the horizon there, and then we're looking up for our angle of elevation of 20, we're looking out, and then down for our angle of depression of 40. And the last piece of information we are given is that the buildings are 30 meters apart. And then we're asked how high up is Ted's window. Okay, so the building are 30 meters apart, so here they are at the bottom, we are 30 meters. This also means that that yellow line I've highlighted there, we're assuming the buildings are straight up and down, that is also 30 meters. And if Kim's looking straight out and then up, or straight out and then down, there's our horizon, that this is going to be a 90-degree angle. So notice we now have two right triangles, and we have to figure out how high up Ted's window is. So what I'm going to do is I am going to split up parts of our triangle here. So I'm going to label this part for our top right-hand triangle X, and then I'm going to label this part for our bottom triangle Y. Now, I've had to split it up like that and not just label it as this large or overall triangle, because we don't have enough information to go on to actually solve it that way at this point. So we need to find the height of Ted's window. So height of Ted's window is going to be equal to X plus Y. So we need to solve for X and Y and then add those two together. So we have these two right triangles, and you'll notice that we have this dashed line, okay, the one that I'm highlighting in blue right now. So those are the hypotenuse of the triangles, and we're not given that, and we do not need to find it. So if we are not going to be using the hypotenuse, that means if we're looking at primary trig ratios, that we're going to be using the tan ratio. So notice that for our top triangle, our side X, that is our opposite side. And for our bottom triangle, our side Y, that is our opposite side. And then they both share this side that measures 30 meters, which is our adjacent side. So we need to do two separate calculations, and then we're going to add those two together. So our top triangle, we have tan of our 20-degree angle, and that is going to be equal to X over 30. So now we're going to solve for X. So X is equal to 30 times tan 20, and that's going to give us approximately 10.9 meters. So we found X, let's find Y now. So tan of 40 degrees is equal to Y over 30, and Y is equal to 30 times tan of 40 degrees. And Y is equal to approximately 25.2 meters. So we need to find our height. So height is equal to X plus Y, so 10.9 plus 25.2. That is equal to 36.1 meters. Okay, so we've gone through all of our steps. So step one was to draw a well-labeled diagram. That's what we've done. Step two is to decide what strategies to use. So we chose to use primary trig ratios to solve, and now we have solved and we've rounded correctly to 1 decimal place, and we have our units here. Lastly, we need to write a summary sentence. So therefore, Ted's window is 36.1 meters off the ground. Okay, let's do one more example. My apologies for all that rustling. So here's our next example. Kyle and Janet leave school and walk to their separate homes. There is an angle of 46 degrees between them. Janet lives 1.4 kilometers from school and Kyle lives 1.7 kilometers from school. How far do Janet and Kyle live from each other? So they both start out at the same location. They start out at school. So I'm just going to put a point here and label it with an S for school. Now, Kyle lives 1.7 kilometers away and Janet lives 1.4 kilometers away. So let's draw in Kyle. So Kyle walks home from school. There he is. So 1.7 kilometers. And let's do Janet as well. So Janet lives 1.4 kilometers from school. And in between them, we have that 46-degree angle that we are told is between them when they leave school. And we are asked to find how far do Janet and Kyle live from each other. So we are going to be looking for this dotted line I just put in there. So let's label our sides. We labeled our vertices. So we have a little j, we have a little s, and we have a little k. Now, we are not told that it's a right triangle and we really don't have any idea if it's a right triangle. So we can't really use we can't use our primary trig ratios here. So that means we're going to use sine law or cosine law. And in this case, we're going to be using cosine law because we have a side, an angle, and a side happening. So case is side, angle, side. Okay, so this means we're going to be using our cosine law. So let's write that in. Let's write in that formula using the letters that I've chosen to label our triangle with. So s squared is equal to j squared plus k squared minus 2 times j times k times cos of s. Okay, let's put in all the information we know. So we don't know what s squared is. J is 1.7, k is 1.4, and we have our angle of 46 degrees. So we have s squared is equal to 1.7 squared plus 1.4 squared minus 2 times 1.7 times 1.4 times cos of 46. Now, most of you at this point can punch it all into your calculator and solve for it in one go, and that's great. I'm going to do just a couple more calculations for those of you who are still having difficulty punching things into your calculator. So we need to see the formula, we need to see numbers in the formula, and at minimum then the final answer here. But I'm just going to do a few more steps. So if we do 1.7 squared plus 1.4 squared, we should get 4.85, okay? And I haven't rounded anything. And if we do 2 times 1.7 times 1.4, that gives us 4.76. And then that's times cos 46. Now, it's important that you recognize that we need to follow BEDMAS as always. And so we need to do 4.76 times cos 46 before subtracting it from 4.85. So you should get that s squared is 1.5434 and so on in your calculator, okay? Don't round yet. So we need to get s by itself, so we're going to take the square root of 1.5434 and so on. And s is going to be equal to approximately 1.2 kilometers. So now we want to do a summary sentence. Therefore, Kyle and Janet live 1.2 kilometers apart.